Hello everyone, and welcome back to Tech Adventure. I hope you're all doing well and staying dedicated to enhancing your skills in software development and embedded systems. This video continues our C++ interview Q&A series, designed to help college students, freshers, and experienced developers ace their C++ interviews with confidence. Previously, we covered 50 real-world C programming interview questions, key topics frequently asked in interviews. If you missed those videos, I highly recommend checking them out for a solid foundation before moving forward. If you find this content helpful, like, subscribe, and share to support the channel and help others on their learning journey. Let's dive and continue our Q&A series on C++. 21. What are smart pointers in C++? Smart pointers are a powerful tool in C++ for managing dynamically allocated memory and ensuring that resources are properly released. They provide better safety and convenience compared to raw pointers. Smart pointers are part of the C++ standard library and are available through the memory header. Here are the main types of smart pointers in C++. 1. Unique pointer. A unique pointer is a smart pointer that owns a dynamically allocated object exclusively. It ensures that the object it points to is deleted when the unique pointer goes out of scope or is explicitly reset. Only one unique pointer can own a given object at any time, and it cannot be copied, but it can be moved using move semantics. 2. Shared pointer. A shared pointer is a smart pointer that maintains a reference count to manage the lifetime of a dynamically allocated object. Multiple shared pointer instances can share ownership of the same object, and the object is deleted when the last shared pointer goes out of scope. It allows for shared ownership, making it useful in scenarios where multiple parts of a program need to use the same resource. 3. Weak pointer. A weak pointer is a smart pointer that does not own the object it points to. Instead, it holds a non-owning reference to an object managed by a shared pointer. It is used to break circular references that can occur when using shared pointer. You can convert a weak pointer to a shared pointer if the object still exists. Otherwise, it converts to a null pointer. Here is the example demonstrating all smart pointers. Have a look. The key takeaways will be, smart pointers help write safer and more efficient C++ programs by automatically handling memory. 22. What is a static member and a static function? Static members and static functions are associated with the class itself rather than with any particular object of the class. Let's break down each concept. Static member. A static member is a variable that is shared among all instances of a class. This means that there is only one copy of the static member, regardless of how many objects of the class are created. Static function. A static function is a function that can be called on the class itself, without needing an instance of the class. Static functions can only access static members and other static functions. Here's an example to show both concepts. The key takeaways here are, static members are shared among all instances. Static member functions and static member data are contained within a class and must be declared. When a function is declared static, only a single copy of the data is maintained for the class. Static functions don't have this pointer object, which points to class objects. Static functions can only access static members. Static functions are useful for class-wide operations. 23. What is exception handling in C++? Exception handling in C++ is a mechanism that allows a program to deal with unexpected situations, exceptions, that occur during runtime. It helps in managing errors and maintaining the normal flow of the program. Here are the key components. Try block. This block contains the code that might throw an exception or error. Catch block. This block handles the exception. It catches the exception thrown by the try block. Throw statement. This statement is used to throw an exception. Here's a simple example. "24. What is a final class in C++? In C++, a final class is a class that cannot be inherited from. This is useful when you want to prevent other classes from deriving from your class, ensuring that the class's implementation remains unchanged and secure. To declare a class as final, you use the final specifier after the class name. Here's an example. 25. What is name mangling in C++? Name mangling in C++ is a process used by compilers to generate unique names for each function and variable. This is done to support function overloading and avoid name conflicts. Name mangling ensures that each function or variable has a unique identifier in the compiled code. For example, consider the following overloaded functions. Even though both functions are named func, the compiler will mangle their names to something unique, like _z4 func I for the integer version and _z4 func d for the double version. The exact mangled names depend on the compiler. Name mangling allows the linker to correctly link function calls to their definitions, even when multiple functions have the same name. 26. What is an L value and an R value? In C++, L values and R values classify expressions based on their ability to appear on the left-hand side or right-hand side of an assignment. L value, locator value, represents an object that occupies some identifiable location in memory. Example, it has an address. Can appear on the left-hand side or the right-hand side of an assignment. Examples, variables, array elements, dereference pointers. R value, read value, represents a temporary value that does not persist beyond the expression that uses it. Can only appear on the right-hand side of an assignment. Examples, literals, temporary objects, the result of most expressions. In modern C++, the distinction between L values and R values is crucial for understanding move semantics and perfect forwarding, which are important for optimizing performance. 27. What are explicit keyword in C++? The explicit keyword in C++ is used to prevent implicit conversions and copy initialization that the compiler might otherwise perform. It is used to prevent implicit type conversions for single-argument constructors. It ensures that objects are only created when explicitly requested, avoiding unintended type conversions. Here's how it works. 1. Prevents implicit conversion in single-parameter constructors. 2. Applies to multiple parameter constructors. 3. Used with conversion operators. 4. Prevents implicit conversion with deleted constructors. Here is example demonstrating explicit in multiple cases. 28. What is the diamond problem in C++? How do you solve it? The diamond problem in C++ is a specific issue that arises in multiple inheritance scenarios. It occurs when a class inherits from two classes that both inherit from a common base class, forming a diamond-shaped inheritance structure. This can lead to ambiguity and redundancy. Here's an illustration of the diamond problem. In this example, class D inherits from both B and C, which both inherit from A. This creates ambiguity because D has two copies of A's members, leading to potential conflicts. Solving the diamond problem. The diamond problem is typically solved using virtual inheritance. By declaring the inheritance as virtual, you ensure that only one instance of the base class is shared among all derived classes. Here's how you can modify the previous example to use virtual inheritance. In this modified example, B and C inherit from A virtually, ensuring that D only has one instance of A. This resolves the ambiguity and redundancy issues associated with the diamond problem. 29. What is difference between const and constexpr? Both const and constexpr are used to define constant values, but they have different use cases and behaviors. Use const when you want a read-only variable, but its value can be set at runtime. Use constexpr when the value must be computed at compile time for performance optimization. Constexpr functions guarantee compile time execution, while const functions can be executed at runtime. Use constexpr whenever possible for compile time optimizations. Here is the example. 30. What are virtual destructors? Why are they needed? A virtual destructor ensures that the correct destructor is called when deleting an object through a base class pointer. This prevents memory leaks and undefined behavior when dealing with polymorphism. If a base class has a non-virtual destructor, deleting a derived class object using a base class pointer leads to incomplete destruction, causing a memory leak. In problem example, only the base destructor is called and the derived destructor is not, leading to potential resource leaks. In solution example, both the base and derived destructors are called, ensuring that all resources are properly released. That wraps up today's session on real C++ interview questions and answers. If you enjoyed the video, please don't forget to subscribe to the channel for more content related to software and embedded development. For a diverse experience, I also encourage you to subscribe to my other channel, where you can explore travel, finance, and updates from around the globe. Links are provided in the description for more details. We'll continue this C++ Q&A series in our next video. Until next time.